All right, welcome to this comprehensive explainer. Let's get straight into it. I want you to think of the Cambridge Physics 9702 exam as a high-stakes, intense culinary competition. The formulas, the definitions, the raw facts, those are just your ingredients. But simply throwing raw ingredients on a plate doesn't make you a master chef, right? You need to know exactly how to cook them through precise analysis and then plate them perfectly through high-level evaluation. To show you what I mean, let's take a look at two hypothetical students taking the exact same past paper question. We've got Alex. Now, Alex memorizes every single formula in the textbook, but then completely overloads the answer sheet with disconnected raw facts. It's just a mess. Then we have Sam. Sam genuinely understands the concepts, but panics under the timer, rushes through the question, and totally misses the specific command words the examiner is looking for. The result? Both of them leave massive, easy marks right there on the table. So today, we are going to look at the absolute perfect recipe for exam success.
Okay, let's dive right into this because it is incredibly frustrating for examiners to see highly capable students lose basic method marks, especially on mass defect and binding energy questions. Seriously, why does this happen? Well, it's because the final numerical answer is literally only a fraction of the story. You could get the math perfectly right and still lose out. Marks in Cambridge Physics are heavily weighted towards your process. I'm talking about your systematic analysis and your evidence-based reasoning. When you look at an exam paper covered in red marks, it is rarely because the student didn't know the physics. Nope. It's almost always because they skipped vital steps in their working out, or they completely failed to show the explicit causal relationships between the concepts. You have to prove how you got from point A to point B.
So, here is our exact blueprint for today's session to guarantee those top marks. Section 1, Core Principles. Section 2, the Method Mark Strategy. Section 3, Processing Complex Nuclear Data. Section 4, Top Examiner Warnings. And finally, Section 5, Mastering Analysis and Presentation.
Let's kick things off with Act 1, Core Principles. These are the fundamental ingredients of nuclear physics, and you need to prep them perfectly before any of the real analytical cooking can even begin.
Now, what's really interesting about this slide is that terms like mass defect and binding energy aren't just vocabulary words you can simply regurgitate onto the page. The 97002 syllabus explicitly requires what they call systematic analysis. When you define mass defect, you can't just stop at the definition. You must also map out the evidence-based reasoning for exactly why that missing mass essentially disappears and transforms into binding energy. You have to explicitly state that causal relationship. If you don't connect the dots for the examiner, they will not give you the marks. It's as simple as that.
Listen to this direct quote straight from a Cambridge principal examiner. They said, top-performing students exhibit connected conceptual understanding transferable to unfamiliar contexts. That last part is absolutely crucial. The exam is actively designed to pull you out of your comfort zone. They are going to throw wild isotopes at you that you have literally never seen or studied before. If you rely on rote memorization, you are going to freeze up the second you see something new. But if you have a connected conceptual understanding, you can take those fundamental principles and apply them flawlessly to literally any unfamiliar context they throw your way.
Moving on to Act 2, the Method Mark Strategy. This is where we start cooking the analysis using a very specific tool called the Peel framework. Your process here is quite literally just as important as your final answer.
Systematic processing in nuclear physics has to follow a highly standardized sequence. Let's break it down. Step 1, identify the key elements and extract your data. Step 2, apply the relevant physics principles. Step 3, execute your analysis and show clear logical working. Step 4, verify those results. And Step 5, present your final answer in the appropriate format. If you try to jump straight from Step 1 to Step 5, you are throwing away massive method marks. The examiner needs to see the entire journey. And by the way, before we continue on to the exact framework to use for this, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, let's look at the difference this makes. Compare our two students here. Look at Alex on the left. Alex just word vomits raw facts. It's a chaotic mess of equations and definitions with absolutely zero structure. The examiner has to hunt for the right answer. Now look at Sam on the right. Sam completely transforms their answer by applying the PLEL framework. That stands for Point, Evidence, Explanation, Link. Sam makes a very clear point, provides extracted data as evidence, offers a solid explanation of the physical principles at play, and then brilliantly links it all back to the specific question asked. I want you to take 30 seconds mentally to just trace that structure on the screen. See how organizing the exact same physics knowledge literally transforms a failing, messy answer into a guaranteed success. That is the power of PL.
Now we're rolling into Act 3, processing complex nuclear data. This is where we learn how to extract the perfect ingredients. But hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, welcome to your first interactive workshop challenge of this explainer. I want you to imagine you are sitting in that dead silent exam hall. You have exactly 60 seconds for a data scan of this table showing values for mass defect and binding energy. Go. What is the core trend here? Think about it. As the nucleon number increases, what exactly is happening to the binding energy per nucleon, and where does it hit its peak? Under pressure, top students don't just stare at the numbers, they instantly extract the overarching trend. In this case, they spot the data pointing directly toward maximum nuclear stability. That's how you win the method marks.
Your ability to process this kind of data quickly boils down to 3 absolutely critical skills. First up, you must accurately extract data from texts and tables. And please, do not misread standard form or prefixes. That is such a tragic way to lose points. Second, interpret the relationships, for example, finding that optimum peak on a binding energy curve. And third, draw evidence-based conclusions. Spotting similarities and drawing relative conclusions based strictly on the data in front of you, not just what you memorized, is exactly what separates an A-grade candidate from the rest of the pack.
Let's move to Act 4, Top Examiner's Warnings. We are opening up the Principal Examiner's Secret Playbook to help you avoid total kitchen disasters in the exam hall.
So, the crucial point here is that these are the top 3 easily avoidable mistakes candidates make year after year, straight from the examiner reports. Number 1. Improper formatting of mass defect and binding energy concepts. We are talking about basic stuff like confusing unified atomic mass units with kilograms. Number 2. Forgetting to check your format and presentation entirely, leaving your working out scattered all over the page like a puzzle. Number 3. Providing answers that are totally generic and not specific to the given context of the question.
Let's do a quick Find the Flaw challenge. Take a look at the generic answer on the left. It reads like a beautifully written textbook definition of binding energy. All the physics facts in there are 100% correct. So why does it score a big fat 0? Because it completely lacks context. Now contrast this with the answer on the right. This context-specific answer weaves those exact same correct principles directly into the scenario they were asked about, specifically referencing the isotopes and the energy outputs mentioned in the prompt. Failing to adapt your knowledge to the specific constraints of the question is the ultimate fatal flaw.
To make absolutely sure you never make these presentation and context errors, I'm going to give you a brilliant on-the-spot memory hack. Remember the acronym FACT, FACT. F stands for format. Is your working linear and logically clear? A stands for annotation. Have you clearly labeled all your steps and your variables? C stands for context. Is your final answer directly linked to the specific scenario in the prompt? And T stands for terminology. Did you use precise, syllabus-approved phrasing instead of casual slang? Run your answer through FACT, and you will lock in those formatting marks every single time. All right, we have arrived at our final act, mastering analysis and presentation. This is all about plating the final dish to secure those highest possible marks.
When you are dealing with extended response questions, there are 3 distinct tiers of critical analysis you have to demonstrate. Level 1 is merely the descriptive level. This is just stating what is happening. It gets you baseline points, but that's it. Level 2 is the analytical level. This is where you explain exactly how and why it happens, proving those causal relationships we talked about. Finally, level 3 is the evaluative level. Evaluative thinking means you are questioning assumptions, comparing different perspectives, and justifying every single one of your decisions with hard, undeniable evidence. This is where the top-tier marks live.
For
For those tricky comparative questions, you absolutely must follow these strict plating conventions. First, you have to identify similarities and differences. Don't just do one or the other. Second, explicitly use comparative connectives, words like whereas, however, or in contrast. Don't make the examiner guess you're comparing things. Third, support every single comparison with evidence extracted directly from the data. And finally, draw concrete conclusions about their relative importance. If you hit every single one of these requirements, you literally guarantee yourself full marks.
Now notice this massive +2 on the screen. Students who implement these physics strategies see an average improvement of 2 grade boundaries. Let me repeat that, 2 full grade boundaries. That is your mark potential rocketing toward 100%, but only if they practice consistently with our weekly explainers. And this brilliantly illustrates our ultimate golden rule, taken straight from an official examiner alert. The classic mistake is providing generic answers. Always link every point to the given scenario. Context is king, folks. Whenever you are writing out an answer, imagine the examiner standing right over your shoulder asking, "Okay, so what? How does this actually apply to the specific nuclear reaction I just asked you about?" Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. So, I want to hear from you. What is your target grade for physics, and what is the absolute biggest analytical challenge you are facing in your prep right now? Drop a comment below with your answers. Our team responds to every single comment. Like and share this explainer with a study partner who really needs a wake-up call on their exam technique. Keep practicing, keep refining your method, and remember, ace the exams. Your Cambridge success starts here. See you in the next one.